Okay, so let's take a look at this demonstration here. During the class, we have calculated the oscillation of the rod and also the stream mass system. And today in this demonstration, I would like to show you that no matter what kind of shape this object is, if I displace the object away from the equilibrium position in this gravitational field, then you see the oscillation behavior, which is actually predicted by the mathematics we work out in the class. So let's take a look at the first demonstration here. It's a rod. If I displace that from the equilibrium position, which is pointing downward, then you see oscillation behavior. It's really very nice. And if you look at also the second demonstration, if I displace the pendulum from the equilibrium position, you also see this oscillation. You can see the oscillation frequency is pretty similar between these two objects, although they look very, very different. And that is actually tuned to have roughly the same angular frequency, as you can see from here. So let's take a look at the other side, the third and the fourth object, which we're not calculating during the class. The amazing thing is that I'm going to show you that the oscillation behavior can also be observed if I displace those objects from the equilibrium positions. And the third object is a circle, although it doesn't have any mass in the middle. If I release that, and you can see still very, very well the oscillation behavior for this empty circle. And the last one, which is the most geometrical one, which is a full disk. If I displace that from the equilibrium position and release that, and you can see very, very beautiful oscillation behavior. The amazing thing is that all those objects, although they have very, very different shapes, they can all be described by the same mathematics which we derived during the class.